All right. Hi guys. Today we are going to cover p-series, which is a series with the form s equaling 1 over 1 to the p, 1 over 2 to the p, 1 over 3 to the p, 1 over 4 to the p, and it just keeps on going. When you see this series written out as a summation or in summation notation, this is the summation of 1 over n to the p. And it converges if our p is larger than 1 and diverges if p is less than 1. So this is a continuation of our geometric series lesson. So if you're in the booklet, you'll see that's why it has example 3 instead of example 1. So it says, do the following series converge or diverge, explain. And so now we're looking at p series. And again, on your formula sheet, it is the third one. So let's look at this first example. It says, do the following, because this is the following series converge or diverge, explain. So let's go ahead and write this out. So we have the summation of 1 over the square root of n, which if we wrote this out, if I plug 1 in, I get 1 over 1 to the 1/2. If I plug in 2, I get 1 over 2 to the 1/2 plus 1 over 3 to the 1/2 plus 1 over 4 to the 1/2. And it just keeps on going and going and going. And so looking at this, there's not much work I need to do. It's already in the form of, notice 1, 2, 3, 4 in the denominator, and then that power just stays the same. So we always have the 1/2 power, 1/2 power, 1/2 power, 1/2 power. Okay, so this looks like that particular form that we're looking for. So this is a p series. And the criteria is our p is equal to 1/2. So that is our power. P is for power. So 1/2, 1/2, 1/2, it stays constant. In this case, it is less than or equal to 1 by the criteria. It is less than or equal to 1. So number 3, the summation of 1 over the square root of n diverges. Okay, so if you just got done watching the geometric series, that feels a little bit backwards. This is when you're on your test, you really start looking at your series. Okay, here's the series, here's my results. Here's if it diverges or converges. Okay, if you were to do this not writing the series out, which is perfectly okay, I would rewrite this one more time. So we had the summation of 1 over the square root of n. This is really the same thing as 1 over n to the 1/2 power. And so then we can label p is equal to 1/2. And so this is a p series. Now, when I am doing these, question I always get is, how did I know that the series is a p series? Well, here, my n is the base. So n is the base of this particular number, and 1/2 a number is my power. So if I have a power that is a set number, say set, and n is at the base of it, n is the number that is changing, or the variable is the base, and a number is the power, that's how I know that this is a p-series. Okay. So let's go on. We have example 4, do the following series converge or diverge? Go ahead and pause the video and try A and B. All right. Welcome back. So A says we have the summation of 1 over the square root of n cubed. Remember that our series, well, first, let me start off. I have n, and it's being raised to some sort of power. And the power is set. So I know that this looks like a p-series to me. That's how I know. Because the n is not in the exponent. The n is the base. So I'm going to rewrite this as the summation of 1 over n to the 3 to the 1/2 power, which is really the summation of 1 over n to the 3/2. So if I'm writing my conclusion, 1, this is a p-series. Definitely confirmed. If I see p-series up at the top here when you're writing, you're changing your summation, I'm just going to assume this is your initial thoughts and not in your steps. So you need to write like a full sentence or something, bullet points at the very end so I can know. Remember, 3 parts. 1, what tests are you using? We're using the p-series test, Katie. 2, the p-series, going back to our form, says it converges if p is greater than 1 and diverges if p is less than or equal to 1. I'm just going to make this larger. We're going to zoom in again. So here, my p is equal to 3/2. Now, is that greater than 1? Is it less than 1? What is this? So if we're not sure, hand it in a calculator. 3/2, 1.5. So this is greater than 1. And our p-series test says it converges if p is greater than 1. So step 3, the summation of 1 over the square root of n cubed converges. Okay, so what test you used? What was the criteria? Because I can't spell today. That is spelled wrong and I apologize. So what is the criteria that we are using? And what is our result? Okay, so we have 3 things: test, criteria, results. All right, so now let's look at the next one. We have the summation of n to the negative 2. Again, this looks like a p-series because n is the base. And a number, a number is my exponent. So, but we need to rewrite this because a p-series looks like 1 over n to the p. And so I need to rewrite it to look like that. If I'm going to claim to my teacher, hey, this was a p-series, I need it to look like a p-series. So we're going to rewrite this. So this is the summation of 1 over n squared. Okay, just one step. If it has a negative exponent, it really can move down. And so step 1, this is a p-series. 2, my p is equal to 2. And my handy-dandy formula sheet says if p is greater than 1, it converges. So p is definitely greater than 1. So step 3, summation of n to the negative 2 converges. Again, if you want to write this out in sentence form, you can. I'm going to be looking for 3 things. What test did you use? We used the p-series test. 2, what was the criteria that this met? P is equal to 2, which is greater than or equal to 1. 3, did it converge or diverge? Did your series converge or diverge? So these are the 3 things that I'm looking for. I'm also looking to see if you got it in the right form. All right. So example 4 continues. Do the following series converge or diverge? Explain. Okay, see, we have n raised to the 0.75 power. So people normally like to start off here and go, hey, your p is 0.75. It is not, because it is positive in the numerator. So we need to rewrite this. This is the summation of 1 over n to the negative 0.75. If I'm claiming that the series is using the p-series test, it better look like the summation of 1 over n to the p. Okay, so now it looks like this. So the first thing I'm going to say this is a p-series test. 2, the next thing, my power is negative 0.75, which is definitely less or equal to 1. So step 3, just double checking, less than or equal to 1, it diverges. So the summation of n to the 0.75 diverges. Okay, we really could have used the nth term test here. Do I have room? Because the limit as n goes to infinity of this. So just a side note. Nth term test. The limit as n goes to infinity of n of 0.75. This equals infinity, so it diverges. Just by the nth term test. Or we can do a p-series test if you're kind of stuck in between using both. Either one. Okay. Example 5 says, what can we say about the following series? We have the summation is n equal 1 to infinity of n squared, 3 over n squared versus the summation of n equal 1 to infinity of 3 over n. And before, if we had used the nth term test here, we would have said both of these diverge, or not diverge, excuse me. If we would have used the nth term test, we would have said we don't know anything about both of these. So what I would do is this first one, this is a P series. 2, power of 1. This is a P series. Again, I know this because I have n as a base and a constant as a power. So 2 is always the power, and the other one, 1, is always my power. So step 2, P is equal to 2, which is greater than 1. Oh. Guys, apparently I can't count today either. Here, P is equal to 1, which is less than or equal to 1. Okay, so let's look at this first one. If P is greater than 1, my P series test tells me that series converges. Converges. Over here, P is less than or equal to 1. So the summation of 3 over n, if I go back to my sheet, it's less than or equal to 1. I don't know why it's not letting me. There we go. It diverges. So 1 converges, 1 diverges. Okay, example 6. This is where most people get confused on their test. Is you'll be given a number of series, and you have to, I'm going to ask you, do these converge or diverge? Tell me the test that you're using, tell me the criteria, and then tell me your result. And I'm not going to tell you which test to use. That is your choice. But this is where a lot of people get stuck. What am I using? So it says identify whether the following are geometric P series or neither. So let's remember, geometric was the summation. Oh, that was geometric looks like the summation of a r to the n minus 1. P series looks like the summation of 1 over n to the p. So in geometric series, my power is always changing. Power is changing. In a P series, my base is the one that's changing. Okay, so let's look at A. Notice here that the base is an N, so that means the base is always changing from sum to sum, but the -3 is set. It's always going to be -3. And so this tells me that this is a P series. Okay, B, if I write this out, I get 1 to the 1 power, plus 2 to the 2 power, plus 3 to the 3 power, plus 4 to the 4 power, plus, and it keeps on going. Notice that my base and exponent are both changing. So since they are both changing, it is neither. All right. And then C, we have the summation of 3 to the negative n. Here, my base is set, but my exponent is changing. So it's 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, and all those are negative. Those are always changing. So looking at these, that tells me that I'm dealing with a geometric series. Or that makes me believe that I'm dealing with a geometric series. So I wrote that up here and realized that my arrow there we go. So geometric series, the exponent changes. Let's write that down. So geometric, the exponent is the one that's changing. In a p-series, it is the base that is changing. All right. All right, guys, that is all I have for you today. If you have any questions, feel free to email me or let me know, and I'll talk to you guys soon. Have a wonderful day.